Now let's do number 2. Figure 7-6D shows that the logistic function f of x is equal to 3e raised to 0.2x over e raised to 0.2x plus 4. So let me write that again. F of x is equal to 3e 0.2x over e 0.2x plus 4. And this is the graph of that function. So letter A, explain algebraically why the graph has a horizontal asymptote at y is equal to 3. So starting with the original function, our original function is f of x is equal to 3e 0.2x over e 0.2x plus 4. So the required for A is y the graph has a horizontal asymptote at y is equal to 3. Okay, so let us begin again. As x is greater than 0 and x is very large. So take an example when x is equal to 100. So when x is equal to 100, well, 100 is not a standard for very large numbers of x. You can use 1,000, 200, as long as they are way, way far from the normal values of x that we use for graphing. Normally, we use a window of domain negative 10 to 10. So in this case, 100 is considered very large. So at f of 100 then, notice that we have 3e 0.2 100 over e 0.2 100 plus 4. And this will give you 3e 20 over e 20 plus 4. And without evaluating the whole thing, and just evaluating our E20, so our E20 is actually 485 billion. Okay, so this point here, or this value here, is 485 billion, or 4.85 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8. So this is very large, and because this is very large, this could be taken as negligible. Therefore, for very large numbers of x, in the case when x is 100, we will be left with 3e20 over e20, and this will just cancel, leaving us a value which is equal to 3. Therefore, it is just reasonable that our horizontal asymptote is at y is equal to 3. That is our horizontal asymptote. Therefore, defining and proving our letter A. Okay? Letter B. Read the point of inflection from the graph. So this is our graph. This 7-6D is our graph. Find the x-coordinate algebraically. So given our point of inflection, we have to get the what is our point of inflection here. The point of inflection is the midpoint of y equals 0 and the horizontal asymptote. So it means that your point of inflection occurs at y is equal to 1.5. Am I correct? So at y is equal to 1.5, you could actually solve for your value of x. Right? So let us do that. So we are finished with A. This is A. So this is b. Okay. So consider that our function, our original function is this one. So what can we do is to compute for our x. So if our f of x is 1.5, and that's equal to 3e 0.2x over e 0.2x plus 4. And multiplying both sides by the denominator gives us 15 e 0.2x plus this is 6 is equal to 3e 0.2x. And then putting this is 1.5. Okay, I'm sorry, this is not 15, this is 1.5. Okay, so this is 1.5. So transposing this here and rearranging the algebra, the terms. So I have 3e 0.2x minus 1.5 raised to 0. Or a raised to 0.2x will be equal to 4. And this will just give me 1.5 e 0.2x is equal to 4. Now setting the natural logarithm for both of the sides, let me see if I overlook something. So this is 6 actually. So 6. 6. So setting now, but we could actually simplify first. So this would give me e raised to 0.2x is equal to 6 divided by 1.5. That's 4. Okay. So this is sweet. We have 0.2x ln of e, setting the natural logarithm. Okay, remember that a logarithm with base e is a natural logarithm. Therefore, we have to use the natural logarithm. So this is ln of 4. And we could just cancel this out. And our x is equal to ln of 4 over 0.2. And therefore, our x is equal to, what is my x? My x is ln of 4 over divided by, or over 2. So divided by 0.2, not 2. Okay. So that's actually 6.93147. So this is 6.93147. Okay, that is my x value for the point of inflection when y is equal to 1.5. So the point of inflection here is actually the point 6.93147 1.5. This is my letter B. Letter C. For what values of x is the graph concave up and concave down? So because we found it using algebra, so for x greater than, so letter D, let's solve it on the next slide. Letter D, for x greater than 6.93147, the graph is concave down. And for x less than 6.93147, then the graph is concave up. Okay. Next. Letter D. Okay, this is letter C. For letter D, the question is transform the equation so that there is only one exponential term. Confirmed by graphing the resulting equation is equivalent to f of x as given. So, what is the given again? What is our given? 3e raised to 0.2x. So our f of x is 3e raised to 0.2x over e raised to 0.2x plus 4. Now let me check it. Yes, okay, we have the correct function. So we're going to transform it now. So what we need is to take out the e raised to 0.2x here. So that's 3e raised to 0.2x over e 0.2x plus 4. And of course, we are going to multiply this by e raised to negative 0.2x over e raised to negative 0.2x. And this will give us, so this one will be cancelled, this will become 1. And in here and here, so in this portion it becomes 1. So we will have 3 over 1 plus 4e raised to negative 0.2x. So this is our answer. Okay, now let us prove. And how do we prove the equations? We're going to get values of x for, or we're going to get the value of y for one value of x. So let us use x is equal to 1, for example. This is the easiest, so let x is equal to 1. I don't like the color, let's replace the color. So when x is equal to 1, let us find for f of x. This is our f prime of x, okay? So this is for this part, and this is for this part. Okay, so where are we? So when x is equal to 1, okay, let us start from here. F prime of 1 is equal to 3 over 1 plus 4e negative 0.21. And in here we have f of 1 is equal to 3e 0.2 times 1 over e 0.2 times 1 plus 4. So let me check it using our calculator. Okay, so let us have the calculator with us. Let's check it. So 3 times e raised to 0.2 times 1 divided by e raised to 0.2 plus 1. This will give us, or plus 4, I'm sorry, that's not plus 1. This will give us 0.0701776. Okay, well in this case, let us check. So 3 divided by 1 plus 4e, where is my e, raised to negative 0.2. So this gives me the same answer, 0.70176. You could confirm this. So meaning that the two equations are the same. So either we use this one or we use this one, they are completely the same. Okay, so that gives letter D for problem number 2. Okay, I hope you caught up with the lesson. So on the next videos, we're going to um, solve number 3 and number 5. Okay, so stay tuned in. So thank you for watching.